the first two are pretty straightforward. It's plot the point with given polar coordinates. So the angle here is 2 pi over 3, which is labeled for you right here. And the distance is -4. Negative means we're going in this direction here. 1, 2, 3, 4. So that would be the point right there. Okay. Here, 4, 60 degrees. Again, 60 degrees is labeled for you. It's right here. 4, this time it's positive, so it's 1, 2, 3. That's where the point is right there. Convert each pair of polar coordinates to rectangular coordinates. 5 pi over 6. Right. Well, where's that going to be? That's going to be over here somewhere, right? Because 5 pi over 6 would go over here. And then 2 would be out this way somewhere. So in order to put them into rectangular coordinates, well, we have r is 2. We have theta is equal to 5 pi over 6. Okay. So we know that x is equal to 2 times the cosine of 5 pi over 6. And y is equal to 2 times the sine of 5 pi over 6. And what's the cosine of 5 pi over 6? Positive or negative? Okay. So this is 2 times negative square root of 3 over 2, which makes this negative square root of 3, right? And what's the sine? Positive 1/2 is 2 times positive 1/2. That equals 1. And so the coordinates of this point are negative square root of 3, comma 1. And just to double check, negative square root of 3, comma 1 puts it, I don't know, right about here somewhere, which would be just about right for the angle. Same thing here. Okay, we know that we have polar coordinates, so r equals -2. X is equal to -2 times the cosine of negative pi over 2. And y is equal to -2 times the sine of negative pi over 2. What's the cosine of negative pi over 2? 0. So this is equal to 0. And what's the sine of negative pi over 2? -1. So -2 times -1 is positive 2. So the coordinates are 0, 2. Just looking here briefly, negative pi over 2, well, that's 90 degrees in that direction, right? And then -2 would be right here, and lo and behold, yeah, 0, -2. What happened there? What happened? Why didn't that work? What did I do? It's a common mistake, and it's something you should be wary of. All right? Negative pi over 2 brings me down to here. What was r? -2. Which way do I have to go? Well, if this is if pi over 2 in this direction right here, then when I go -2, I need to go this way. Just like we did over here. We came around here, but then when we did negative, we went this way. So if I'm doing polar coordinates and I have an r of -2, when I figure out what the angle is, I've got to go backwards along that angle. So now we're going to find all pairs of polar coordinates that describe the same point. -4, 15 degrees. Well, here's 15 degrees. And here's -4 is 1, 2, 3, 4. So it's right here. Okay. when it says find all, it means all, which is infinite. There's an infinite number of them. So basically, we've got two ways to go here. We've got coming all the way around this way to 195 degrees, right? And positive 4. And I can add 360 n to that. I can go around and around and around as much as I want. And of course, we've already been given negative 4, 15 degrees, and I can add 360 to that as well and go round and round and round and round. And so those are, taken together, all of the different ways that you can write the coordinates of that point. 3, 0, on the other hand, well, let's see. We've got 0 degrees and 3, so that's the point right there. Obviously, I can write that with any multiple of 360. And if I go around to here and go negative, right, that would be negative 3, pi. Oh, and since we're not dealing with degrees, so that would make this 2 pi n. And this would be pi plus 2 pi n. That would be all the different possible ways to write this.
Well, if it's negative 3, how is it the same point?
Because if I go around pi degrees, or pi radians, I get to here, right?
Yeah.
And then if I go negative, I have to go that way, don't I? Yeah.
So when we're writing this, we don't need to write it with the negative angle. So we wouldn't need to write it like 3, negative pi. We don't need to do that?
Well, that would be included here, because if this was negative 1,
Oh, right. Okay. I see.
right?
That makes sense.
Anybody else? Questions? Okay. Convert each pair of rectangular coordinates to polar coordinates. And in this case, they want r to be greater than 0, and they want the theta to be somewhere in the first rotation. So we have rectangular coordinates. That means r is equal to the square root of 3 squared plus 1 squared, which is equal to the square root of 3 plus 1, which is the square root of 4, which is 2, right? X is equal to r times the cosine of theta. And we know what x is. It's square root of 3. And y is equal to r times the sine of theta. In this case, it's 1. Y is 1. So that means the cosine of theta is square root of 3 over 2. The sine of theta is 1 over 2. And that means that theta is equal to pi over 6, which means r is 2, theta is pi over 6, so the polar coordinates here are 2, pi over 6. Convert each pair of rectangular coordinates to polar coordinates. Well, that's what we just did. Right? These are rectangular coordinates, so r is equal to the square root of 0 squared plus negative 3 squared. R is equal to the square root of 9. R is equal to 3. Okay. X is equal to r cosine theta. Y is equal to r sine theta. So we're looking for an angle that has a cosine of 0 and a sine of -1, and that's going to be 270 degrees. Right. We've got our R, we've got our angle, so it's all the way around. This is the terminal side of that angle, and following the terminal side of that angle, we go 1, 2, 3, and there we go. That's what this point is. 3, 270 degrees. Okay. Notice we're using a method here that doesn't require you to think in terms of quadrants or anything else. This just leads you directly where you need to be. So here, R is going to equal the square root of negative square root of 5 squared plus negative square root of 15 squared. So R is going to equal the square root of 5 plus 15. R is going to equal the square root of 20, which is 2 square root of 5. Now at this point I think we'll bring some other paper over here. We've figured out that R is equal to 2 square root of 5. So this is A plus BI, right? Okay. R is going to be this squared, the square root of this squared plus this squared. That's right. A is equal to R cosine theta. That's exactly right. We have A as -5, right? And that's equal to 2 square root of 5. Actually, A is equal to negative square root of 5. It's equal to 2 square root of 5 times cosine theta. Right? Divide both sides by 2 square root of 5. That means cosine of theta is equal to -1/2. Right? And B is equal to R times the sine of theta, which means this is going to be negative square root of 15 over 2 square root of 5, which is negative square root of 3 over 2, and that's the sine of theta. What angle is that going to be? Has a cosine of -1/2 and a sine of negative square root of 3 over 2. 240. So that's going to make this R cis theta. The next problem, number 10, is given in this form: 4 cis 5 pi over 4. So R times the cosine of theta plus R times the sine of theta. What is that? Okay. Times I. And then simplifying that out, that's going to be -2 square root of 2 minus 2 square root of 2i. 11, number 11 was 5i, which is the same as 0 plus 5i. So R is equal to the square root of, plus 5 squared. That's square root of 25, which is 5. And 5 is equal to 5 sine of theta, and 0 is equal to 5 cosine of theta, and in this particular case theta is going to have to be 90 degrees, so this is going to be 5 cis 90 degrees. Number 12 is square root of 31 cis 315. degrees. What is the cosine of 315 degrees? Okay. And what is the sine of 315 degrees? Okay. Well, that's going to leave you with square root of 62 over 2 minus square root of 62 over 2i. Number 13, that's 0 minus square root of 10i. That's going to be this point right here, isn't it? Where this distance right here is negative square root of 10. At this point, I think we could just sort of jump to the point where we say it's square root of 10 cis 270 degrees. This is 270 degrees, and then this is square root of 10. How do you find the absolute value? The absolute value is going to be equal to that plus that. Is that right?
Yeah.
Okay. Which is going to be 4 times 3, so this is 12 plus 4, square root of 16, it's 4. Because the absolute value is the distance of the number from 0, which is the same as the definition for absolute value on a number line in the real number system. Distance from the number to 0. Okay. Plot each point in the complex plane using polar coordinates. Well, there's no graph for you here, but how would we go about doing this? Here's your theta, here's your r. Pi over 4 brings you here. 2 square root of 3. Well, square root of 3 is about 1.7, and 2 times that would be about 3.4. So 1, 2, 3.4. In using rectangular coordinates, this would be 1, 2, 3, 4, 5, 1, 2. The thing to remember here is that when we're doing these dots, we're not talking about a location anymore. We're talking about a number. These represent a number on the plane, in the same way that when we were using a number line, this didn't give you a location as much as it did, as much as it represented the number 2. Yeah.
So if you were like trying to represent a location with a complex number, would you use parametrics?
If you were trying to represent a location on a plane, then those would just be polar coordinates, and then, for example, this point would be 2 square root of 3, comma, pi over 4.
Okay, you just use
Right? It's the difference between polar coordinates and a complex number in polar form.
What if you were trying to do like
Okay. The idea here is you have 4 cis 11 pi over 6 times 2 cis 4 pi over 3. Okay, you multiply the 4 times 2, you get 8. And you add the angles, 11 pi over 6 plus 8 pi over 6. So that would be 19 pi over 6. We could actually simplify that, couldn't we? No? Because 19 pi over 6, well, this would be 12 pi over 6, right? And then 7 more pi's over 6. So wouldn't this be the same as this? It should be between 0 and 2 pi.
okay.
I mean, ideally. Okay. Simplify and write your answer in rectangular form. Yeah, it's a distributive property. So this is going to be equal to 6i plus 2i squared. And 2i squared is 4 times negative 1, so it's negative 4 plus 6i. Find all nth roots of square root of 13 cis 120. Now you got to remember that 120 is the same as plus 360n. And we're going to raise that to the 1/5 power. Yeah, you need 2 sets of parentheses here. One to sort of keep those in check, and the other to get the whole thing. That's going to make this square root of 13 to the 1/5 power cis 120 divided by 5 would be 24 plus 360 divided by 5, which would be 72, I think. Okay, times n. Since we're looking for the nth roots, we're looking for all of the values between 0 and 360. So this would be that 10th root of 13, or if you prefer, 13 to the 1/10 power, cis 24, 13 to the 1/10 power, cis 96, right, adding 72, 13 to the 1/10 power, cis 168. And you just keep going till you get past 360. Cis 0, carry the 1, 240. And then 13, 1 square root of 10. Cis 312. And if I add 72 to that, it gets me over 360. So 1, 2, 3, 4, 5. There are 5 fifth roots. Where did the 1/10 come from? Well, here, this is the same as 13 to the 1/2 power raised to the 1/5 power, right?